Digital media has an inescapable limit. Your publishing volume is tethered to your physical working hours. When you stop clicking, the output halts entirely. The traditional video editing process requires a human operator to scrub through timelines, trim clips, and sync audio. This is a linear treadmill. You spend 10 hours of labor to buy 10 minutes of finished media. Current consumer AI tools attempt to accelerate this, but they are highly fragmented. A script generator requires a written prompt. A voiceover tool requires a text file. An image generator needs exact manual oversight. Because a human operator must physically move data across these disconnected applications, the human remains the primary bottleneck. The individual tools process faster, but the pipeline itself is broken. Achieving true enterprise-level volume means the human cannot be part of the execution phase at all. The entire manual sequence must be bypassed. The objective is to transition your role from an editor working inside a timeline to a director who simply hands off a master blueprint to an automated system. As long as your output depends on physical clicks, reaching scale remains a mathematical impossibility. The Troveto tech engine removes the manual execution layer entirely. It functions as a centralized, fully autonomous production system. Its core capability is straightforward. It takes simple, structured spreadsheet data and converts it directly into high-quality, branded video content without a single manual edit. This is achieved through a process called agentic orchestration. The system links localized language models, headless web browsers, and cloud APIs into a cohesive network that triggers action sequentially. To understand how this zero-touch publishing operates, we will map out its specific 5-stage architectural pipeline. The primary engineering challenge here is severe, sequencing multiple disparate systems securely without triggering pipeline failures or exposing sensitive data. Deconstructing this sequence reveals the exact system architecture required to decouple your media output from your physical effort. The entire autonomous cycle begins with a standard spreadsheet, specifically a file formatted as syllabus.xlsx. The agent initializes its process strictly by parsing the subject name and topic details columns. Open-ended chat prompts lead to unpredictable outputs. This system instead relies on deterministic intake, forcing the instructions into a predictable, machine-readable format. That single string of data acts as the absolute baseline. It establishes the rigid parameters that will govern every decision made by the downstream AI agents. From the moment this file is loaded into the intake folder, the human user has zero further interaction with the system. By stripping the initial instructions down to a rigid data structure, a highly variable creative process can be controlled entirely by automated logic gates. Once intake is parsed, the neural research phase triggers. The central master orchestrator, powered by localized Ollama models, directs all subtasks directly from the hardware. It begins by deploying a headless Playwright browser to autonomously scour the web and gather assets. Because it doesn't waste compute power loading visual interfaces for a human to look at, this scraping compiles research at absolute lightning speed. Simultaneously, the orchestrator initiates a secure login to Notebook LM, establishing a dedicated, isolated workspace for the project. The raw data from the headless browser flows directly into this workspace. Notebook LM is then instructed to ingest these exact assets and synthesize them into a comprehensive deep dive explainer script. There is no copying, pasting, or flipping between tabs. These distinct processes execute simultaneously. By pairing an aggressive scraping tool with advanced cloud synthesis, the system constructs a fully researched, structured pre-production foundation in absolute isolation. Next, the pipeline moves into its most computationally heavy requirement, post-production and rendering. Here, we encounter a strict enterprise limitation. You cannot pipe sensitive corporate data through public APIs without risking exposure. Troveto solves this by shifting the rendering process back behind a strict local execution environment. The data leaves the cloud and locks down locally. Inside this localized engine, the system applies your channel branding. It rigidly inserts your specific logos and pulls your cinematic intro clips to maintain a consistent visual identity. Functional elements like animated chapter indicators and progress bars are generated and placed accurately across the video file without anyone ever opening an editing timeline. The engine also executes global localization, automatically translating the content to reach regional audiences while maintaining 100% audio completion. Executing this locally provides a secondary engineering advantage. You completely bypass recurring cloud computing costs, even when running massive batch processing jobs. Shifting post-production to local hardware creates a structural privacy wall around proprietary business logic, while eliminating the recurring costs of cloud compute. With the MP4 fully rendered and sealed on the local drive, the file must now be prepared for the public internet. The local machine executes a precise handoff protocol. It securely opens a singular pathway, allowing the finished video into a specialized cloud integration layer. The file connects to the Gemini API, which analyzes the narrative context of the final rendered video. Using this analysis, the agent generates its own visual asset, a high-resolution, high-conversion thumbnail featuring vibrant overlays and bold typography. It simultaneously outputs the metadata, autonomously generating optimized titles, accurate tags, and highly structured SEO descriptions based strictly on what occurs in the video. Utilizing a language model for the packaging phase guarantees that the final asset is engineered for algorithmic discovery the exact second the local rendering finishes. The final hurdle in the pipeline is executing the autonomous upload directly to the YouTube platform. Cloud delivery systems possess an inherent fragility. If a strict pipeline encounters an API timeout or an upload rejection, the delivery process is instantly compromised. In standard automation scripts, a single point of failure at this stage acts as a hard roadblock, crashing the entire batch process. The Troveto engine prevents this by implementing a passkey gateway paired with multi-account failover protocols. If an upload triggers an error, the system detects the failure and instantly routes the video to a secondary backup account. The upload completes without a single manual restart. To close the feedback loop, the system pulls the live published URL from YouTube and writes it directly back into your original Excel spreadsheet. High availability failover mechanisms are the critical difference between a brittle automation script and a true enterprise-grade engine. This is the completed 5-stage architecture, operating in continuous unison. This pipeline is a full systems integration. It is structurally superior to simple generative wrappers because it connects entirely separate computing environments. It relies on a specific triad of functions: strict local control to ensure data privacy, targeted cloud computing for rapid research synthesis, and multi-account failovers to guarantee delivery. Because of this architecture, the operational capability scales perfectly. You can drop a 100-row syllabus into the intake folder, step away, and sleep while the engine autonomously produces 100 localized branded videos. The transition from a pending concept to a completed, published asset is now a mathematical certainty, entirely independent of your labor. By replacing the editing timeline with an orchestrated agentic pipeline, you permanently bypass the bottleneck. Your publishing volume is finally decoupled from your physical working hour.